Hey guys, I just figured I'd make this video for some help with the Mythbusters collision video that you just watched. Hopefully, y'all enjoyed that video. And in the video, we noticed that they slam a car into an immovable object, right, as their experiment. In that initial experiment, they dropped the two from two different heights in order to achieve twice as much velocity in that higher one. Remember that the x speed, speed x, and speed 2x. Okay, so first question, if you want to just follow through with me. When looking at the clay that was squashed in between the two heights, how do those clays in the slower collision compare to the ones in the faster collision? So what's the key difference there? You'll just write that right there for me. Okay, then they take the immovable object out and they insert a second car on the left side and they drop it from the lower height, both of them. So does that clay squished from both of those look more like the higher speed or the lower drop speed from the experiment with the immovable object? Okay, and then it asks, why does this happen? Okay, well, a a key thing that they talk about that happens in science, of course, is for every action we have an equal and opposite reaction, right? And that's Newton's third law. Okay, and you can elaborate more on that if you wish. On number four, he wants us to calculate the impulse of the car on the right during the collision with the immovable object. And if it gives us the mass of the car is 3 kilograms, and it's going 2 meters a second just before the impact and stops after the collision. All right, guys, continuing forward. Sorry, I got interrupted by those announcements, but I went ahead and put some of the formulas here. So I wanted us to calculate the impulse. Remember, impulse is labeled with the letter J of the car on the right during the collision with the immovable object. Okay, it gives us the mass and the velocity just before the impact and stops after the collision. Okay, so change in momentum is mass times velocity final minus mass times velocity initial. In all these cases, we can just write the mass 3, right, times whatever your velocity final is minus 3 times whatever your velocity initial is. Okay, I don't want to like completely do it for you, but just think you only have two things that are happening here, before and after. The final one is what's happening after. So what's happening after the collision, right? What's happening after the collision? Okay, so what's the velocity if it's stopped? You're gonna put that number here. And now before impact, right? There's your velocity. You're gonna put that one here and solve. That's how these work. Okay, now it wants you to calculate the impulse of the same car raised to the second height going 4 meters a second just before impact and stops again after. So you'll do that same concept on number 5, same equation. Okay, so now the two cars collide. We notice that they do not bounce apart from each other. What type of a collision is this? Is it elastic or inelastic? Now don't just write exactly what I put. You need to pick one. It's one of those two. It's not bouncing apart. So is that elastic or inelastic? Which one is it? Okay, you're going to write your answer there. Describe the conservation. How the conservation of momentum law is true for this collision where the two cars go and collide together. Okay, well, somehow in your statement you need to show that your momentum before is equal to your momentum after. Right? Well, they have equal and opposite momentums because they're the same car going at the same speed. So the momentum before, right, it should be equal and opposite, which means if you add them up, it should be 0. And after the collision, they're stopped. So if they're both stopped, you add them up, still 0. Something along those lines, describe it there. Okay, if one of the cars is already in the down position, which is stationary, okay, that's 0 meters a second, and the other was released from the second height, 4 meters a second, just before collision, what will be the speed of the two cars upon collision? Okay, so this is an inelastic collision, and since it's an inelastic collision, we can write the equation mass 1, velocity 1, plus mass 2, velocity 2. After the collision, right side, now they're combined, so we add up, we combine their masses, and they're going to have the same velocity. So I'll help you out with this one to start it off. Okay, and then you'll solve from there. Mass 1, well, we said they're both 3. That was from the other side. 3 times velocity 1 plus 3 times velocity 2, right? Because they're both mass 3. On the right side, we know that they're both mass 3. Now, what's the velocity of our first one? Okay, one of the cars is already in the down position. We'll say the first one was 0. Okay, car 2, which is on the right, was released upon the second height. Okay, so car 2 was released, bam. It's going 4 meters a second, just before collision. So there it is. Simplify left side, do the math. You can do it. Okay. Then you'll calculate the impulse. Okay, so the impulse of the two cars from the example below, mass, you already know their masses are 3. Velocity final, whatever's this is your velocity final for both of these, minus your velocity initial. Well, car 1 initial is going to be 0. Car 2, you know that the velocity initial is going to be 4. Velocity final, again, is what you're solving for on this problem. Okay, so how does this compare to the impulse of the car dropped from both heights into the immovable object? Okay, so you're going to compare that. Should be the same. One of them should be the same. Okay. Was the immovable object really immovable? So now you're going to look at the 544 kilogram immovable object, and you're finding the speed of the immovable object after the collision. It's going to be a very small number. Okay, so we'll say that our immovable object is our object 1 plus mass 2, that's 3, and it's going how fast? After the collision. Oh, let's just say that this one, velocity 2, is 4. Okay, and mass 1 is 544, because that's the immovable object, plus mass 2, 3, times v. And you're finding the v. You're solving for that. Okay, so that's what you guys are doing. It's going to be a very small number. It's velocity, so meters per second. Okay, then read that last one and answer it on your own. Good luck, guys. Hopefully this helped. And I will talk to you all later. Goodbye.